Welcome to this Class 10 icse Mathematics lesson on proving trigonometric identities. In this video, we will learn 3 reliable categories of proof and work through 3 examples in each category. An identity is an equation that is true for every permitted value of the angle. Our strategy is to start with one side, usually the more complicated side, and transform it step by step into the other side. Remember these tools? Tangent theta is sine theta over cosine theta. Cotangent theta is cosine theta over sine theta. Secant theta is 1 over cosine theta and cosecant theta is 1 over sine theta. The 3 fundamental identities are sine squared theta plus cosine squared theta equals 1 plus tangent squared theta equals secant squared theta, and 1 plus cotangent squared theta equals cosecant squared theta. Category 1 uses quotient and reciprocal identities. Replace named ratios with sine and cosine, then cancel only common factors. These proofs are often one substitution away from the answer. Example 1. Prove that tangent theta multiplied by cosine theta equals sine theta. Start with the left-hand side. Replace tangent theta by sine theta over cosine theta. Then sine theta over cosine theta multiplied by cosine theta equals sine theta. The cosine factors cancel. Therefore, the left-hand side equals the right-hand side and the identity is proved. Example 2. Prove that cotangent theta multiplied by sine theta equals cosine theta. Replace cotangent theta by sine theta over sine theta. We get cosine theta over sine theta multiplied by sine theta, which equals cosine theta. Therefore, the left-hand side equals the right-hand side and the identity is proved. Example 3. Prove that secant theta divided by tangent theta equals cosecant theta. Replace secant theta by 1 over cosine theta and tangent theta by sine theta over cosine theta. Dividing by sine theta over cosine theta means multiplying by cosine theta over sine theta. The cosine factors cancel, leaving 1 over sine theta, which is cosecant theta. The identity is proved. Category 2 uses the Pythagorean identities. Recognize a familiar pattern before expanding or cancelling. The 3 formulas are sine squared theta plus cosine squared theta equals 1 plus tangent squared theta equals secant squared theta, and 1 plus cotangent squared theta equals cosecant squared theta. Example 1. Prove that 1 plus tangent squared theta multiplied by cosine squared theta equals 1. Start with the left-hand side. Replace 1 plus tangent squared theta with secant squared theta. Now, secant squared theta multiplied by cosine squared theta equals 1 over cosine squared theta multiplied by cosine squared theta, which is 1. The identity is proved. Example 2. Prove that 1 minus sine squared theta divided by cosine squared theta equals 1. From sine squared theta plus cosine squared theta equals 1, we know that 1 minus sine squared theta equals cosine squared theta. Substitute this in the numerator. Cosine squared theta divided by cosine squared theta equals 1. The identity is proved. Example 3. Prove that secant squared theta minus 1 divided by tangent squared theta equals 1. Use the identity secant squared theta minus 1 equals tangent squared theta. The expression becomes tangent squared theta divided by tangent squared theta, which equals 1. The identity is proved. Category 3 uses algebraic simplification and factorization. We will use the difference of squares, multiply by a conjugate when rationalizing, and combine fractions over a common denominator. Example 1. Prove that the product of secant theta plus tangent theta and secant theta minus tangent theta equals 1. Apply the difference of two squares. We get secant squared theta minus tangent squared theta. Since secant squared theta equals 1 plus tangent squared theta, the result is 1. The identity is proved. Example 2. Prove that 1 plus sine theta divided by cosine theta equals cosine theta divided by 1 minus sine theta. Start with the left-hand side. Multiply the numerator and denominator by 1 minus sine theta. The numerator becomes 1 minus sine squared theta. By the fundamental identity, this is cosine squared theta. So the expression becomes cosine squared theta divided by cosine theta multiplied by 1 minus sine theta, which equals cosine theta divided by 1 minus sine theta. This matches the right-hand side, so the identity is proved. Example 3. Prove that the square of tangent theta plus cotangent theta equals secant squared theta multiplied by cosecant squared theta. Rewrite the bracket using sine and cosine. Tangent theta plus cotangent theta equals sine theta over cosine theta plus cosine theta over sine theta. Combine the fractions. The numerator is sine squared theta plus cosine squared theta, which is 1. Thus, the bracket equals 1 over sine theta multiplied by cosine theta. Squaring gives 1 over sine squared theta multiplied by cosine squared theta. Finally, replace 1 over sine squared theta by cosecant squared theta and 1 over cosine squared theta by secant squared theta. The result is secant squared theta multiplied by cosecant squared theta. The identity is proved. Here are 5 exam-ready habits. Start with one side only. Do not cancel across addition or subtraction. Write one algebraic step per line. State the identity you use and convert to sine and cosine when the expression is complicated. These habits make identity proofs clearer and safer. Let us recap. Category 1 uses quotient and reciprocal identities. Category 2 uses the 3 Pythagorean identities. Category 3 uses factorization, rationalization, and conversion to sine and cosine. With these methods, many identity proofs become systematic rather than mysterious. If this lesson helped you, press like, subscribe for more icse mathematics videos, and turn on notifications. Keep practicing and remember, simplify one side carefully until it becomes the other. See you in the next lesson.